the last type of fuel we're going to talk about is biofuels. Oh. So these are fuels that the main two we're going to talk about is ethanol and biodiesel. We might have heard about these in kind of everyday usage, maybe. Biofuels tend to be have more pros in terms of environmental impact. So these fuels tend to release less CO2, um, and they tend to be coming from renewable sources. And so what's interesting, just a little side note, is that wood is considered a biofuel. Um, but we find that the most common way that we can, so how do we get so if we talk about, let's first talk about ethanol. So ethanol, how do we get that? To make ethanol, we're going to start from a sugar. So we can get sugar from a lot of different agricultural products. Corn is probably the most common type of source for this sugar, though we can use other types of products as well. We can actually use corn husks. There's just tons of ways in which, so if we use something that's not just a straight sugar that we can extract, we can also, like corn husks from corn, we can use those if we implement a bacteria to break those down. Those or we'll talk about something called starches. We can get those from the starches. We can get those sugars out as well. And so there's lots of different ways to get to the sugar component. But once you're there, so this is glucose. So C6H12O6, this is glucose. And so we can make two ethanols. So two ethanols, which is going to be C2H5OH. So we got 6 hydrogens, 2 carbons, and an oxygen. This is ethanol. And then 2 CO2. So we'll be talking about in the process of brewing. We will also be using a glucose or a sugar fermentable. And this is basically, this whole process is, so fermentation. Where we're converting glucose to ethanol. So there are different ways we can do this. But again, we'll leave it at that for right now. Ethanol produces less energy than gasoline. So it produces less energy than gasoline. But it can be blended. So you probably have seen like E8, E10. So it can be blended with gasoline. Most places and states, it's up to 10%. Now, some engines do not like that, especially two-stroke engines or singles. So the your lawn, like your lawnmower and your blowers, anything that's kind of the smaller engines really don't like that ethanol, and you have to go with a premium. But you can use these, and it's up to 10% to kind of reduce some of those emissions. And like I said earlier, this glucose can come from many sources, though for political and other reasons, the corn industry tends to be one that has been utilized the most. But to use farmland specifically to grow corn to make ethanol is not the most environmentally friendly. Use of farmland. Again, there are pros and cons to ethanol as a energy source in that you are giving up one thing for another, so you're making a cleaner um, fuel, though not as energy efficient. But to do so, you have to grow lots of corn, and that agricultural land could be used for other things. So again, be aware of that. So we talked about two. So ethanol is one type of fuel. Biodiesel is another type of fuel. So biodiesel, um, we used to do a lab on biodiesel. We actually would make biodiesel, um, but we can't do that now. And so I'm gonna show you what to do. So you're gonna start off with two components. One is triglyceride. So in a triglyceride is just a fat or an oil. The difference between a fat and an oil, we'll talk about that tomorrow, is going to be if it's a solid or liquid at room temperature. So in either case, we've got this carbon chain, this 3-carbon chain with an oxygen off of each carbon. And then we have a structure of carbon that's double bonded to an oxygen. And then we have these R groups. Now the R groups are so R equals a group that is unique to the fatty acid. So it could be CH3, it could be C2H6. It could be basically a very long chain or a shorter chain, but basically it's a long hydrocarbon chain. So hydrocarbon, so long hydrocarbon chain. And so to save space, we don't write that, but it can actually be much longer than that. And so this is what we call, so we'll label this in red. So we call this a triglyceride. And then this R group we call the fatty acid chain group. So mainly because it has a long hydrocarbon chain. And now we react our fatty acid. I guess we'll think, so what is a triglyceride? So it could just be vegetable oil or animal fat. So in the biodiesel lab, we just took vegetable oil that we bought at the store, and you react that with methanol. So if you get 3-methanol, CH3OH, this is methanol. And you react those two together, you would get, we're going to move this down, so we're going around the room, you would get as a product, and you would have, in the lab we did this is potassium hydroxide, this is a catalyst. Basically it makes the reaction happen much faster for room temperature. You would get, you would still have your 3-carbon chain that we started with from our fatty acid. They would still have their hydrogens attached, CH in the middle, CH2s on the ends. But instead, what's happened is, see how we have, do this in green. So see how we have the, so these right here, these are going to attach to this CH3, I'm going to attach right here. And so what you end up getting is the OH. So this O group, O, attaches. This H just gets put on the end here, and here, and here. So we'll do that part first. So we get C. I'm going to keep the colors consistent. So we have O, 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 and then that hydrogen comes on from the methanol. so this hydrogen, and then what's left is our this group right here, and we're going to add this to it. So what we get is, we'll do it in black. We get our three of these, 3CH3. That was what we got here, CH3O. And then, well, actually, we'll do this in green so that we can see where they're coming from. So we'll do everything in green from the methanol. So we go back here, and we'll say green. So we have CH3O. And then what's left is what's coming up from here, our C double bond O. What's in orange there? R. So we got C double bond O, R. Okay, so in these two things, so these are our two products. These are our products. And so let me, so this right here, this is glycerol. Not super useful, doesn't have a high energy content, glycerol. And with this right here is there's two names for it. One is called a fatty ester. Ester is just a type of compound that has an oxygen linking two carbons. Don't worry about that. Or biodiesel. Biodiesel is another word for this. Okay, so our biodiesel, so what we really care about is right here. And so to summarize, we take a fat, a very common found, so a triglyceride, so it can be anything. So this is how when people take, so if we do a little story here, story time. So we have McDonald's, and they make all their French fries. But in doing so, they have tanks and tanks of fryer. I'm not sure if it's a Y or an I. We're gonna say it's an I. Fryer oil that they just gonna put in the trash. So along comes someone. So we got in a Volkswagen bus. And they've converted it to a biodiesel bus. And they say, I'll take your fryer oil. So they take their fryer oil and they can convert it using commonly found chemicals. So a base and methanol. You can use sodium hydroxide too, very easy. Methanol, not that hard to find either. And you can produce pretty readily and easily biodiesel. Convert your engine to run on biodiesel instead of gasoline, and basically you get gas for free. You have to do the work, but this is how a biodiesel bus would run. So that is another way in which we can make a fuel out of a naturally occurring, in this case, instead of a sugar-containing compound, we are having a fat or an oil, and we can use a chemical reaction to make biodiesel or a fatty ester, which has a pretty high energy content, and again, can't run off a internal combustion engine, but is pretty good at it as well. So that's biodiesel and ethanol.